Welcome back. I hope you enjoyed that bit of a break and you were able to stretch and relax a bit and get your energy flowing back. So, yeah, let's get back to it. Um, as I said, please use this link to download the Cube IDE. After you hit that link, you have to scroll all the way down and it says where get software. And if you are using a Windows um, PC, then you have to get the Windows installer, so STM32Cube IDE, and you have to click on Get Latest, and this will start to download the files. So once it's downloaded, these are all the steps you have to follow. It's pretty much easy, but not to scare you, I just given you almost every screen that you will face when you start to download and up to when you finish the installation. Um, so it's all pretty much follow on the instructions on the screen. So just follow the screen instructions, and you can keep this as your reference, and you can just follow step by step. So from it starts from hitting the get latest, and it will download a .exe file. You have to double click on that. It will always be downloaded as a zip format, so you need a special software called WinRAR or WinZip where you can extract all the files and start to do your installation. You have to say yes, and then pretty much from here just say next, and then I agree to the license agreement, and then it will ask where the destination folder have to sit. You just click on next. By default you will get the destination folder located to C drive, and then once it starts it will start to extract files, and then it will ask you to tick on both drivers. That's essential, so please tick both the drivers and then click install. It will start to install, and then once it's all happy and joyful, it will give you a message as installation complete, and the final screen will look like this: STM Microelectronics Cube IDE, and it will give you information that it has been installed on your computer. But please remember to tick this desktop shortcut. It is easy when you do it here, otherwise you need to go into the IDE and you need to do the options. That's a bit complicated for a starter, for a beginner like you, but yeah, please remember that to click on create desktop. I also did a short video on how to install from step 1 to the final bit. I'm posting that after this, so you can also keep that as your reference and follow that. So once you downloaded the IDE is where you write the code and compile without errors. Then for that code to run without any problems within your host machine, that is your PC, you got to install mysys2.org. So you have to hit on this installation link, and then you have to look for mysys2. It's all by default, and then browse, and again you have to follow the steps just I marked like this. So once it's downloaded, then please enable the run button, and then start to install, and then it will start to run, and then the end message will also say completing the MC64 bit, and then you can run it from here by clicking on that button. So after step 2, on a command prompt window, please type in msys2, and you would see something like this, msys2, and the prompt will be ready to receive your next command. So on the after you type the msys2, this is the shell script that you'll get. It takes roughly about 20 seconds to get the shell script, and this is where you're going to update the system packages in order to get normal transition without any error. You have to do all these initial setups. This is also part of the architecture extensions where you have to set up all of this. So in this is where you're going to do a system update. So update the package, database, and base packages. Sometimes the setup file will come automatically in its own zip folder. If not, it will take at least 2 steps. So don't worry, I also did another short video to show you exactly what to do, so follow that. also follow the screen prompts that with these slides. So all you have to do is the dollar comes and blinks automatically. All you have to type is pacman space dash SYU, capital SYU, that is pacman, that is packet manager short form, that's a term, PAC man minus system update. So after you hit enter, this is what happens. It starts to progress by fetching all the necessary files, and you'll see the warning, please ignore all the warning, it's just doing its job. And it will ask now and again, would you like to start, would you like to proceed? So always hit yes and press enter, and once it's done, you will get a message saying you it is ready to install. So at this time you have to do another tool chain link. So this is to connect your GCC compiler with the system package. So this is the command. So pacman minus s needed. So the whole thing copy and paste and hit run. And you get into this screen where it throws you about options with which MinGW you have to install. So we are targeting to install MinGW 64 because it's a 64-bit processor, so that's why we targeting number 3. So after 3, if you hit enter, then it does all sorts of checks. It has to load all the 28 sections of the files, and once it's all downloaded and installed, and you will get with your desktop number and sits at the prompt. So that means it's all installed and ready to go. And then once you install the IDE and the system updates, then you have to set the environment to make your variables work and link with the program. So these are all the steps you have to follow. Again, it's simple and easy. Just follow the prompt, follow the screen instructions. So on the search, just type in environmental variables and hit enter. You will get this window. On this window, click on path and then click on new. When you come to new, you have to basically link both the EMSys64 and MinGW64 bin. So follow the sequence of left and then the right, then the right, then down, then left, then down, then left, then down, then left. So if you just follow this order, then you would simultaneously end up like this, adding 2 files. And once you're done added successfully with the MSys 64 and MinGW bin, then there is a OK button which is hiding there. I couldn't put that into the screen, but yeah, click that OK button, and the environment variables is all set. So that's all you have to do. IDE, sys 30 sys files, system update files, and the environment variables. These 3 are the necessary files that your computer need to have for your code to work. Otherwise, you can't compile and see the output of the code, whatever you're writing on the editor window. So just to test the compiler whether you got all the MinGW files are installed correctly, so again you go into the command prompt and type in GCC, and you'll get a fatal error, ignore that. And after that you type in where GCC, and you'll get this path. If that path comes you with the .exe, that means yay, you have done your job, it's installed correctly. If not, don't panic, please go back 3 slides and start with IDE installation, then the system update package, then the environment variables. You will eventually end up in here. Also, for your reference, I'm going to include those 2 videos. Please do also follow that videos, and you will be able to do it all by yourself. So you are ready now. You got everything covered and all the tools necessary for writing your own program, and this is how you're going to generate or create a simple project in your IDE. So connect the target board. So this is the target board, and that's the USB pin. So with this pin, it comes with a cable, so you need to connect that to your USB port of the PC. So that's the illustration. So this board is a Nucleo F411 board, and it connects via this SWO pin through the ST link, the debugger and the programmer, and connects to the PC. I'll show you how when the next time when we do the real-time debug. I'm going to show you how, but this is how it's connected to interface with the IDE. So that's the target where you're going to focus on. That's the USB connector, and that's where it's connected. Okay, let's talk about serial wire debug. The serial wire debug is the way to program your target board. So ARM introduced this from JTAG. JTAG is a joint test association group which can be done with 4 pins. In order to reduce the number of pins, they introduced this, and all you need to do is you need to have only 2 lines. It operates on the bidirectional data line and a clock line, and through this 2-wire transform you can actually program, send or load the program to the target board. And it happens on the ITM unit. The ITM is an optional application-driven drive. It supports printf style debugging when you want to see the printf and actually want to see the output in the console window. This is where comes in handy, and this is sitting inside the your processor. So serial wire debug SWD is a 2-wire protocol for accessing the ARM debug interface. In case if something you got bugs or anything, you also have to use this serial wire debug, and it will help you to debug. So as I said earlier, so the SWD stands for serial wire debug. It's a 2-wire protocol to access the ARM debug interface. It's an alternative to JTAG, Joint Test Access Group, and SWD is a part of debug specification version 5. It has 2 physical layers and it has 2 lines. SWDIO, it's a bidirectional data line, and a SW clock. With these serial wire data debug interface, you should be able to program memory control unit internals flash to access to the memory regions, to add breakpoints, and you would be also able to stop and visualize what's happening in the breakpoints, and also you can run the CPU as well. So the other advantage of using the SWD is you can do debug options with printf, meaning with console outputs. If you want to see your output in the console rather than on the target board, on the actual board, you can see it on the console window. So that's where the SW is really handy to have. So thank you for ARM for introducing such a easy tool. So it is very easy and cool when you get to programming. It's all very, very exciting. So I'm sorry to bore you with all the theory so far, but these are all the essentials you need to know. This will also help with your interview questions. You will feel more confident because you are learning the theoretical part and how you're going to link that to your hands-on. So this is all necessary you have to learn. So how the transition happens from JTAG to SWD. So the JTAG was used as a traditional mechanism to debug. It started in ARM 7 and 9 families, and then when the Cortex M family was released by ARM, they also introduced this SWD to make it to make life easier for the software design engineers. So they also reduced from 4 pins to 2 pins. So with the 2 pins, you would be able to program that. And also, it has the additional serial wire output pin, which is used for a serial view wire viewer, which is a low-cost tracing technology. You can actually view the data points where it's all connected. So this is how the connector looks like, and that's the JTAG pin description, and this is the SWD pin description. So it can run on low voltage, 3.3 volts with 2 lines, software clock and serial wire clock and serial wire data. So these 2 are the pins, and the serial wire is to locate to view. Now let's discuss about the debugging options on embedded core. But before that, I'll give you 5 minutes break, and I'll catch you soon after the break, and we'll go through all of this. There is few little things to cover, so I'll catch you in a while. Thank you.